Hi there, welcome back. We've got to the stage now where I'm comfortable to actually power this up completely, and just to tell you what I've done since we last spoke, I've actually just changed that capacitor, the one that feeds the grid of the power tube. I've set it up with a speaker. I've set up the multimeter to measure the B++, just so we can get an idea of what that's at. I have this on at maximum volume. I'm going to put it on gramophone first, because what I'm going to do first is actually just feed a signal into the phono input. See if we've got audio. That's the most important thing for now. So what have I got going in? I've just got a 600 Hertz signal, about 200 millivolts, well, exactly 200 millivolts RMS, going into the gramophone input. The ground of the signal generator is just connected to the chassis. So what we're going to look at first is see what happens when we actually power this on. So I'm going to put it on. I've got it on one lamp only, all the others are off. Limit is on, and I'm going to switch it on, and we'll see what happens. Now, if there's a short on the other tubes, this thing's going to glow very brightly, and we'll know we need to switch it off pretty fast. Well, let's go for it. No direct shorts. And the voltage is going up. Let me show you. And it's already come down just in the time it took me to move the camera. It's actually pretty low. We do have maximum restriction on, and I already hear there's our tone. So our power amp is working. I'm not sure. This thing is very noisy. It's a 200 millivolts RMS signal, and it's not as loud as I thought it would be. Let me try it a bit higher up. Okay, it's not bad. Put that down a bit. The pot is really scratchy. So what I'm going to do now is 122 volts. That's pretty low. I'm going to give it another lamp, and we've got 188 going in now, so I'm going to give it another lamp, and that shot up to 211 volts. The volume is about the same. Our multimeter is now at 186 or 7. And we'll give it another lamp. That's up to 220, drawing 150 milliamps. And our B++ is now at 224. I'm going to give it the final lamp, which means I'm putting in a 200 watt lamp in series with this. That's the minimum restriction. Our voltage, the AC has gone up to 225, and our B++ is up to 235. Not quite at the 260 it's supposed to be, but there is still some restriction. Now, if I bypass it, I'll show you what I'm going to do, and then we'll see the voltage. Okay, I'll move this around a bit. I've got the 4 lamps on, and right now it's just hovering around 230. And I'm going to bypass it. So when I bypass it, it means that these the lamps that are in series here will be completely bypassed, and the radio will be connected directly to the mains. So that should go up to the normal mains voltage, and we'll see what that goes up to. So here we go. Mains 230. And that thing is going up to 243, 244. So not too far off the 260, not quite there, but not bad. This could simply be a slightly tired rectifier tube creating a higher than normal voltage drop, but it's not too bad at all. 240, 245, it's good enough. That should do it. All right, now we're going to try the reception. Just before I do that, for safety's sake, I'm going to put the limit back on. The B++ drops a little bit, but it's not a problem. So what we're going to do now is flip this over to radio, put the volume up. That antenna there is the mini whip antenna that I have on the roof. Pretty good reception, so let's see what we've got. I've got this on band 1, volume's on max, and I've got the speaker pretty close to the microphone here, and I'm not hearing any noise. Band 1 is medium wave. I'm hearing bugger all. Could be the switch. Band 2, bugger all. Let's see what band 3 does. Ha! Can you hear that? Receiving something very, very low on here, but it's getting something. Let's try band 4. There's something there. Yeah, the speaker is literally touching the microphone. It's very, very low, but it's receiving. Yeah, band 4's got something. Let's try 5. Damn it. Yes.
Understand that some security interests, our economic interests.
Just hear something there.
Our connection to our European partners on the migration.
There we go.
Require us to engage in building.
It's getting something. Band 6. This is that high frequency band. I don't expect much on here, except maybe on the one end. Okay, well that's not too bad. Very, very, very faint. But I'm getting something on 3, 4, and 5. These are shortwave bands. Not getting anything on 1, 2, or 6. 6 is that sort of high frequency one, which goes from, what does it go from? 17.6 megahertz to 27.3 megahertz. Quite honestly, I don't often get much there anyway, so it could be working and I'm just not seeing it. So I've got possibly a problem with 1, 2. I've got a problem with all of them as regards the amplitude. It's very, very low. So, and it's also not very selective. I mean, I'm getting a few things. I should be getting a lot of stuff on here. And 1 is medium wave. I should definitely be getting a lot of stuff on here. So we've got some work to do. Now, just had a thought. Okay, this low reception could be caused by so many things, but it could be weak tubes, it could be capacitor problems, it could be also detuned IF transformers. somebody could have messed around with that and really detuned this thing. Someone could also have messed around with these guys over here and detuned the front end. But there is a way of checking one step of this, and that is to check if the oscillator is working on all bands. Because if the oscillator is not working, then it doesn't matter what you tune into, it just won't create that higher frequency modulated. So you won't get anything. So the first thing I'm going to do is set this up so I can check if the oscillators are working. Let's get on with that. I'm going to use a little coil here, which is just a few turns of wire, insulated. And this thing is connected to BNC. That BNC cable is connected to the scope. Okay? And I'll show you what I do. I'm going to put this near the tuning capacitor. So this is insulated, it's insulated wire. So I'm just going to move it around here somewhere, and watch the scope. And I should be able to see the oscillator frequency. Now, depending on where I put it, I'll get a stronger or weaker signal. So I'll start with it just here, and I'll show you the scope. I've got it on that band 4, which we know is receiving something very low. And I'm actually seeing something on the scope. Now let me move it around and you'll see what happens. This thing gets weaker and stronger depending on where I put it. At the moment, it's actually near one of the capacitor terminals, which makes sense because one of these gangs is used as part of the oscillator circuit. So what I'm seeing here is actually the oscillator frequency, and it is at 9.7 megahertz. Now if I turn the tuning, watch what happens. Turn the other way. 9.7 megahertz, 9.9, 10 megahertz. Goes a bit crazy. Just depends where I trigger it. 15 meg, well, it's going to start going down. But I'm definitely getting a oscillator frequency on there. Let me turn it to band 5. Oh, that's even better. Band 5, we've even got a clearer signal. So that oscillator is working on band 5. Turn it to band 6. Ooh, that's a strong one. There we go. That's at 19.7 megahertz. Now that means that we try something here. We go the other way. 19.45, well, about 19.45 megahertz. That means that the front end of the tuner should be at 19 megahertz, which means the difference between the signal I'm tuning to at the front and the oscillator frequency should be 452 or 455 kilohertz, whatever the higher frequency is. So when the oscillator is producing 19.452, I'm actually tuning to 19 megahertz. So if I had a 19 megahertz signal here, or just under 19 megahertz, I can do that. Let me do something here. I'm going to get the signal generator. Let's just try this. I'm going to set the signal generator to 19 megahertz. 19 megahertz. I'm going to send an audio signal, 600 hertz signal, modulated 30%. So I'm sending a 19 megahertz carrier with a 600 hertz signal modulated 30%, which means if I tune to 19 megahertz on the dial, I should hear this tone. Now, where's this tone going to go to? This tone has got to go into the antenna input. Antenna input through a dummy antenna, which I'm going to use this. It's just a resistor in here with a capacitor here, and I'm going to put this. Let me show you. I'm going to connect this to the end here, and I'm going to stick this into the antenna socket. But to do that, I'm going to give it a very small amplitude, call it 10 millivolts. Okay, 10 millivolts. If I put this into the antenna socket at the back here, I can hear a tone. Ha! Watch. It's actually on maximum, very low, but I can hear a tone. Let me just tune a bit more. There's my tone. And actually, I think this has just told me what's wrong with this radio. I think I know what's wrong, why this thing is so deaf. I've tuned it to the peak amplitude here. Okay, that's when the tone is loudest. And look at the frequency of the oscillator. The oscillator frequency, I'll put the volume down. At best reception of this tone, the oscillator frequency is 19.443 megahertz, which means that my IF is not set properly. I think what I'm getting here, I should be, to tune into a 19 megahertz signal, I should be at 19.452, because that's the IF frequency. That's where I should get the loudest signal. And I'm not doing that. I'm getting it at 19.443. So I think someone's messed with the IF transformer tunings. I think somebody's messed with these guys. So I think perhaps what we have here is an untuned set, which is pretty common. That's the first thing people play with. Although there's a plastic tape on the front. I'm not sure that it looks like someone detuned this, but the tape is on there. Obviously they could have taken it off and put it back. So what do we know so far? We know the top 3 bands worked. Let's see about the others. So I'm putting the tone signal generator off. We don't need that anymore. We know that band 6 works. We know that band 5 works. 4 works. What about 3? This is band 3 now. 6.4 megahertz. Does it tune up and down? I'm moving the tuning. Yep, that's working. So we've got ourselves oscillator working at that frequency as well. Let's try band 2. Is that a real signal? Yep, it's tuning. It's changing, which is what it's supposed to do. Let's try band 1, which is AM, and oh dear, I'm not sure that's working at all. No, it is. It is. 1.3 megahertz, that's about right. 1.2, 1.1. Yeah, our oscillators are working. Anyway, that's an easy way of checking if your oscillator is working. So the oscillator is working on all bands. The medium wave is receiving, actually I think there's only one band there that we can receive something on, but at least we know that every, or parts of this are working. Now it could be, the tubes could be weak, it could be untuned, the IF could be untuned, a lot of things could be just off here, but there is nothing completely broken on the RF section, because it is receiving a signal, so which is great. And so the next step is actually clearer now. I'll say the next step is clearer because what I need to do now is swap out capacitors first. See all the black ones there? All these guys have to get changed. This is in the audio section. That is that capacitor that I changed out, C55. There's a couple of those down there, some more up here. There is not much, as far as those caps are concerned. In here, there's not much. The caps they have in here, they've got a couple. Yeah, that's one of them there that needs changing. There's another one down there. Some of them may be ceramics, which don't really need changing. I need to check some of these resistor values. I certainly need to clean out. You see, those are the wafers on the switch. Those need to be very carefully cleaned out. This could be part of the problem. And so what I'm going to do now is I'm going to swap out all the capacitors I think I need swapping. I'm going to check all the resistors I believe need checking. And then we'll switch on again together and see if we've made any difference. The thing to do, actually, I won't be able to do it that way, but I'll report at the end. What I'm going to do, and this is the best way to do it, is I'll swap out 3 or 4 caps, check it again, make sure that it's the same or better than it was before. So if something goes drastically wrong, I know where I've messed up. And it's so easy to mess up, believe me. If I did the whole thing and then switched it on and it didn't work, I wouldn't have a clue where to look for the problem, because you can cause problems when you're trying to fix them. So I swap out 3 or 4 caps, check if it works the same or better than it was before. I move on to the next 2, 3 or 4 caps, and so on and so forth. So at the end of this recapping, I'll report back and we'll see if we have any progress. If we don't, then I have to start swapping out tubes, because that could be the other problem. This is certainly def, which means I need to align it. But before aligning, obviously I need to change out any components that need changing. So that's the next step, recapping and checking component values.